This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. It's definitely important to know what speed and duplex are, especially when it comes to troubleshooting our network. Because if we have some kind of severe network slowness, but it's only with one host, speed and duplex can be a common problem that we need to check out and make sure that that's not the culprit. So here we're going to talk about what speed and duplex are, and later on we're going to see exactly how to configure it. So let's start with duplex. First, there's half duplex, and this is communication one way at a time. So a common example of this is a walkie-talkie. When you're talking on a walkie-talkie, you can't hear the other person. You have to actually unpress the button, then the other user has to press the button, and then they can talk and you can hear them. So it's one way at a time, and half duplex and Ethernet only uses one twisted pair. So this is actual Ethernet cable. If you cut it open, this is what it looks like. There's 4 twisted pairs of wires. Here's one twisted pair, and that's all half duplex Ethernet is going to use. So communication is going to flow this way, or it's going to flow this way. It can't flow both ways at the same time. And then there's full duplex. Full duplex is actually going to use 2 twisted pairs so that communication can go either way. So communication going out, we'll use this twisted pair, and communication coming in, we'll use this twisted pair, and they'll never run into each other. So we can think of full duplex more like a phone, where you guys can actually talk at the same time and hear each other. So there's no collisions in full duplex mode. And full duplex is actually twice as fast as half duplex. So if we've got 100 megabits per second network running at half duplex, when we run it at full duplex, in theory we can get 200 megabits per second, but that's only a theoretical speed. But just know that we get twice the throughput with full duplex because we can talk both ways at the same time. And because we have basically dedicated lines for communication going out and communication coming in, there aren't any collisions in full duplex mode. And because there are no collisions, we have to have a point-to-point connection to run full duplex mode. So like a host to a switch port, or a switch to a switch, or a host to a router, or even a host to a host. As long as you don't have a hub involved, basically, then you can run in full duplex mode. So if we have hubs, we're going to be running at half duplex. And you can see here it says dedicated switch port required for each full duplex node. And a network card and switch must be capable of running in full duplex. And that's normally the case nowadays. But just know that not all networks technically can run full duplex, but realistically today, you're going to be hard-pressed to find one that can't. Now let's talk about speeds. We've got 10 megabits per second. This is also known as Ethernet. 100 megabits per second, and it's important that this is a little b here. We're talking about bits per second, not bytes per second. So 100 megabits per second is fast Ethernet. 1,000 megabits per second is gigabit Ethernet. And 10,000 megabits per second is also called 10 gigabit Ethernet. So these are the different speeds we're going to see in an Ethernet network, and we're going to take a look at cables here in a second. But in order to run at a certain speed, both the network interface card and the cable have to be able to support that speed in order to run. So let's say a host is connected to a switch with an Ethernet cable. The network card in the host has to be able to run at, let's say you're trying to run at gigabit. The network card in the host has to be able to support gigabit speeds. You have to be able to use the right cable that supports gigabit speed, and the switch port that you're connected to has to be able to support a gigabit speed. So if one of those components is missing, you're going to drop down to a lower speed, whatever is supported on all 3 pieces. Where problems come in with speed and duplex is when we have things set to auto-negotiate, and we're going to see how to configure our network cards and our switches here in a second. Let's take a look at a network card real quick. Here I'm on a Windows 7 machine. I'm just going to right-click on one of my network cards, go to Properties, click on Configure, go to Advanced, and we can see here we have speed and duplex, so we can set it. By default, most switches and network cards are set to auto-negotiate. So when you connect your cable to your network card and your switch, they'll auto-negotiate to the highest speed and duplex they can possibly go to. Notice here I can set this one at 100 megabits per second half duplex, 100 megabits per second full, 10 megabits half, and 10 megabits full. Now where a problem can come in is if you have a speed and duplex mismatch. Let's say you've hard set this to 100 megabits half, and then the switch port is hard set to 100 megabits full, or maybe 1 gigabit full. Then you'll have a speed and duplex mismatch, and communication will just it almost won't even work, because one side is expecting things to come at a faster speed or a different duplex than the other side. So that's going to cause a problem. Another problem comes when we have auto negotiation set and something causes the speed and duplex to negotiate down to a lower level. Let's say we've got a bad cable or a bad network card. We think things are supposed to run at gigabit speeds, but really they're auto-negotiating down to, let's say, 100 megabits per second or even 10 megabits per second. Well, then the network really slows down, and we're not sure why, but it actually only slows down for this particular host. Well, that could be because maybe you got a bad cable or network card that's causing this auto-negotiation to negotiate down to a lower level.